As we continue to solve for y here, the key is we want things in the proper form of y equals mx plus b. This is the form we're going to be using in algebra to graph lines. It's the way that, in general, if we have lines in this form, they can be more useful to us and we can use more tools that we're going to learn. So all of the lines that we have in front of us aren't in this form. We're trying to get it so that the y is alone on the left-hand side and there's an understood just 1 in front of that y. For the first few problems, that's just going to mean moving one thing. Specifically, this x term that's currently on the left side has to move to the right. When we're moving something that's on the wrong side, we do it by using the opposite sign. So here we have a negative x, the opposite of that is positive, so I'm going to add positive x or positive 1x to each side. On the left-hand side, that just leaves me with y because these are equal and opposite and will go away. Just having the y over here is our goal, so we have solved for y. We now just need to resolve what's happening on the right-hand side. When I go to combine 7 and positive 1x, I realize one of them has an x in it, one of them does not, so they're not like terms and cannot be combined. We have to leave them separate. Technically, it would be fine to write this as 7 plus 1x. Mathematically, that's correct. But really, I'm looking to this form and saying what will be more useful to me in the future is if I set it up as the x term first and the no power of x term second. So this positive 1x comes first, or just is written as a single x. Then this positive 7 comes after it. So what started as y minus x equals 7 becomes y equals x plus 7. Same idea for problem number 2. This x is on the wrong side. I need to move it to the right-hand side. In order to do that, since it's currently a positive x, I'm going to subtract x from each side. When I do that, over here these go away and just leave me with y equals, which is what I was hoping to get. Over here I have 3 minus a 1x. Again, these are not like terms. They cannot be combined, so keeping them separate, I'm going to list the x term first, negative x, and then the no power of x term, positive 3. When I go to do problem 3, this negative x is what needs to move. I undo a negative x by adding x to each side. That leaves me with just y on the left-hand side. On the right-hand side, I'm combining a negative 2 and an x, which are not like terms. So I'm going to leave it as the x term written first, and then the term with no power of x. That gives me my final answer, y equals x minus 2. Last problem like this, where we just have a single y to begin with, is y plus x equals 14. Again, I'm going to move the x first by doing minus x to each side. That's going to get rid of them on the left-hand side and just leave me with y equals. On the right-hand side, I'm going to rearrange them to say negative x term first, and then plus 14 second. I cannot combine them because they are not like terms. When we get to problem 5, we now have a second step. The second step is going to be, because there's a number in front of the y, we're going to need to divide everything in the problem by that number to get it alone as a single y on the left-hand side. We still need to move the x's first. So what starts as 2y minus 12x equals 6 begins by moving this 12x to just get y's by themselves on the left. To do that, since it's currently a negative 12x, I'm going to add 12x to each side. When I do that, my left-hand side just becomes 2y because these go away. It's going to be equal to these two terms which cannot be combined. So I'm going to leave it as 12x plus 6. This is a correct rearrangement of the problem, but it's not in the correct final form that we're looking for, y equals mx plus b. To get it there, we have to take what's currently in front of the y, a 2, and divide each term in the problem by it. Really, we can see this 2y as 2 being multiplied by y, and we undo multiplication with division. The same way we saw this as y, we were subtracting something that we undid with addition. We were adding something that we undid with subtraction. So basically, we're just using the opposite operation, or the inverse operation, if you will, to undo this. So on the left-hand side, we currently have 2 times y. To undo it, we're going to divide by y. Those 2's are going to divide out and just give me 1y on the left, which is what I was hoping to do. Whatever I do to the left side of the problem, I also have to do to the right. In the case of multiplication or division, I have to do it to each term individually on the right. So what used to be 12x is now being divided by 2, and what used to be 6 is also now being divided by 2. I'm putting an arrow here to say this equation has now become this new equation. Specifically, these 2's reduced to just give me 1 over 1 or 1y, which I can write as y equals 12 divided by 2 gives me 6x. 6 divided by 2 gives me 3. So again, these problems should start the same way that the early problems did, where I'm making sure that only the y's are on the left and that everything x's and numbers has been moved to the right. It just has that additional step of seeing, well, if there's something in front of the y, we need to divide each term by it. In problem 6, we start by moving this 12x, negative 12x here, negative 12x here. That leaves me on the left-hand side with 3y. It's now equal to negative 12x plus 6. I can't leave it as 3y because I want just 1y, so I divide by what's in front of the y, in this case 3. I do that to each of the other terms. This equation now becomes 3 divided by 3, leaves me with just 1y. Negative 12 divided by a positive 3 gives me negative 4 for the x term. That x stays. Then a 6 divided by 3 gives me positive 2. So I get a final answer, y equals negative 4x plus 2. In problem 7, I start by subtracting 35x minus 35x. I then have on the left-hand side 5y is equal to negative 35x plus 5. What's in front of the y, I'm going to divide each term by. When I go to divide 5 by 5, I'm just left with y, which is what we were hoping for. When I go to divide negative 35 by 5, I should be left with negative 7x. When I go to divide 5 by 5, I should be left with a positive 1. So my final answer is y equals negative 7x plus 1. So far, when we've had to divide each of these things, everything divided evenly and I got all whole numbers. Starting in problem 8, we're now going to have some fractions appear. Fractions actually aren't as bad as we normally think they are for these because they're actually really going to help us with this m or slope of lines when we go to graph them. So specific to this process, it really does make sense to leave things in terms of fractions as opposed to putting them into decimals because the decimal doesn't really help me with graphing a slope. So you're going to see in these problems and in all the answer choices, when we're doing any of this division where it's not working out evenly, we're going to leave it in terms of a fraction. So I begin by doing minus 5x to each side. These go away and just leave me with 4y on the left. On the right-hand side, I have negative 5x plus 16. I now divide each term by what's in front of the y, or in this case 4. These go away and just leave me with y. When I consider the x term, I really want to see, can this be reduced? So if instead of negative 5 over 4 it had been something like negative 6 over 4, I'd want to say, well, 2 goes into both 6 and 4, so I'm going to reduce that fraction. In this case, I can't reduce negative 5 over 4, so I'm going to leave it as negative parentheses 5 over 4x. I'm writing it this way just because that's how it's displayed whenever I'm doing these problems in Canvas, but you absolutely could leave it as a fraction like this, negative 5 over 4x, and that would be mathematically correct as well. When I go to do the division on this number, 16 divided by 4 just leaves me with a positive 4. So my final answer is y equals negative 5/4 x plus 4. Same idea in problem 9. I start by moving the x term, plus 2x plus 2x. That leaves me on the left-hand side with 3y. On the right-hand side with 2x plus 18. I can then divide everything by what's in front of the y, in this case 3. And that will get me to my final answer, where the 3's go away and just leave me with y. 2 divided by 3 can't be reduced, so I leave it as 2 divided by 3 for the x term. 18 divided by 3 gives me the whole number 6. So I get a final answer of y equals 2/3 x plus 6. In problem number 10, I'm going to start by moving the 2x. So I'm going to subtract 2x, subtract 2x. These will go away and just leave me with 8y on the left. On the right-hand side, I'm going to be left with negative 2x plus 40. I then divide everything by what's in front of the y term. On the left-hand side, 8 divided by 8 just gives me 1y, or just y. When I then have negative 2 divided by 8x, this is a case where I can actually reduce. 2 goes evenly into 2, 2 goes evenly into 8. 2 goes into 2 one time, so I'm going to leave this negative outside and get a 1. 2 goes into 8 4 times, so this reduces to negative 1/4. If you wrote it as negative 2/8, it would be mathematically correct, but it might not get picked up by a system that was trying to get you to answer it because it's not fully reduced. Assume that whenever you're trying to solve for these y's, they want fully reduced fractions. So here I'm going to put an x next to it. When I then go to do 40 divided by 8, that should give me a positive 5. So my final answer here would be y equals negative 1/4 x plus 5.